Chapter 5 Database Processing. This chapter is a very important chapter because database is one of the most important components of information systems. So for this chapter, the most important takeaway for you guys is the purpose of database. Why do we need database and what roles database play in an information system? If you guys still remember this graph, in chapter 1 we talked about 5 components of information system, and I mentioned over and over again in the class the 5 components: hardware, software, data, procedures, and people. And data, as I mentioned before, data is basically the data, raw data, the records or raw facts that is stored in information systems, and that is processed by information systems to turn into useful information. As I said, the whole purpose of information systems is to turn data into useful information. So to do that, we need to at least have raw data first. And basically, database refers to the data that is processed by information systems. So what is a database anyway? Database is self-describing collection of an integrated records, which means that those records are connected. What does it mean? The records basically means just think records as Excel spreadsheets that has many different tables. Let's say that we have some records about students, and we have some records about professors. And in reality, professors and students are related. Why? Because professors teach students, right? So in reality, students and professors, they are connected some way, and which also means that the table about students and the table about professors, they are also connected because of this relationship. That's why we are saying that database is a collection of integrated records, because in reality, all those data should be related somehow, okay? And as you can see that the data or database is a necessary part or component of information systems. Without data, then there's nothing for an information system to process. Okay. I made this little animation to quickly show you guys how an information system works. Let's say that this information system is PyReport, as I said before. The PyReport is a typical example of information system. Students, faculties all use PyReport to process the information, to find the information they need. So let's say if you guys are the users because you use PyReport. And in order for you guys to use PyReport, you open the browser on your computer, and then you open PyReport, the website. The website of PyReport is basically the applications of the whole system, the user interface of the system, is the software part of the system. So you guys, let's say if you want to search class information of MIS 363. So you open PyReport website, and then what you do is that you send your request to the server, the computer that runs PyReport. So you send a request to it, and then PyReport, the server, receives your request. And the next thing system does is to send your request to the database. Okay, database is managed by database management system. Basically, it's a software that manages all the data. It may be on the same computer with the applications. It may be on a different computer. But anyway, PyReport, the website server, will send your request to the DBMS management database management system. So then the database management system will search the information you need. In this case, it is information about 36.3. It will search the information you need in a database, such as course, course name, location, time, instructor, etc., etc. So you find all the information you want in the database. And then, you will return all the information you need back to the PyReport server. Next, the PyReport website will return the information you need to your computer eventually. So this is basically how an information system works. And as you can see that we have to have a database, right? And this is the role played by database in the whole information system. And let me quickly show you guys how a database in reality looks like. This is an actual database that I quickly created in Microsoft Access. If you guys have installed Microsoft Office 365, then you should have it. So if you search Access, you will find it in your computer. It's part of the Microsoft Suite, Office Suite. And it is one type of DBMS database management system that is used to manage database. So this is a database I just created. In this database, there are two tables. As you can see, we have a student table that has all the student information, student ID, student name, major, advisor name, right? And then we have the advisor table. It has all the information of advisors, advisor name, department, age, etc. So this is a database, just very small database. So just want to give you guys an idea of how a database in reality looks like. What is the purpose of a database? As I just said, the purpose of database is to store and organize the data. And database usually keep track of multiple themes. A theme basically is a thing that one table is about. Let me show you guys what it means in a real database. So in this database, as you can see, there are two tables, student table and advisor table. So each table is about one theme. Student table is about student. So the theme of this table is student. And advisor table is about advisors. So the theme of this table is advisor. So that's what it means by themes. Because usually a database has many different tables, and one table is usually about one thing, and we call it themes. Okay. And the other characteristic of database or tables, as you can see, usually one table has many columns. Okay, in this student table, it has 1, 2, 3, 4, 5 columns. They are called columns. They are also called fields. Usually, those columns are the characteristic about this object, about this theme. For example, student table. The student table's theme of student table is students. So all the columns are basically the characteristic about the students, right? Student number, name, their scores. Those are the records about one fact or one aspect of student. And then you have rows. They're also called records, right? You have many rows. Each row is about one instance of student because this is a student table. So each row is about one particular student. which has all the characteristic, has the record for all the characteristic. It has student number for this particular student, Andrew Baker. It has um, his, her number, student number, name, and scores. And then lastly, we have characters, which are basically the actual data, letters or numbers that are stored in this table. So this is a hierarchy of data elements. First of all, you have tables. You have all the tables, different tables. And then you have rows or records. And then you have fields or columns. And then lastly, you have bytes or characters. And then lastly, you guys should be aware that in database, as I said, the tables are usually connected with each other. What does it mean? Okay, let's show you in this database in reality I just created student table and advisor table, and as I explained, they are connected because students and advisors, they are connected in reality, and the tables are connected as well. However, in database, when we say two tables are connected, we say that when two tables actually share a common column. What does it mean? It means that there is a column. There is a column that's common to both tables. So in this case, which column is it? If we look at the student table, it has student ID, student name, major, advisor name, right? And if you look at this advisor table, it also has advisor name, department, and age. So which column is the common column to both tables? In other words, both tables have the same column. Which column is it? Is it advisor name, department, or age? Yes, the answer is advisor name, right? Because student table has advisor name. Advisor table also has advisor name. So this is a column that is common to both tables. In this case, if there is a common column to both tables, we say that those two tables are connected. Okay, they are connected through this common column advisor name. So this is something you guys should know when we say that two tables are connected. Just like this example in the textbook, we say that the student table and office visit table are connected because there is a common column, which is student number, right? Student number is the common column between those two tables. Question 3, what is a DBMS? What is a database management system? As I just explained, a DBMS, database management system, is basically a software that is used to manage all the data. Okay, because we have to store the data somewhere, right? We can't store it in Paraport, the website. The website does not, the website only processes the user's request. So we can store the data in the website, but we have to store it somewhere. We have to use some kind of software to actually store and manage all the data. And this kind of software is called database management system. Okay, a database management system is a program that is used to create, process, and administer a collection of self-describing integrated records. And there are many different vendors or companies that uh, provide DBMS, such as IBM, Microsoft, Oracle, etc. I just show you guys that this database, which is created in Microsoft Access. Microsoft Access is a type of DBMS. Okay. And of course, there are some other vendors that provide DBMS as well. And the functions of DBMS. DBMS can create database and its structures. It can process database. It can search the information we need, and it can be used to manage a database. I'm not going to go into much details about functions of DBMS. The last thing I want to mention is the non-traditional DBMS. Microsoft Access or other type of DBMS such as Microsoft SQL Server, they are the traditional DBMS that are still used by many companies. However, many other companies, especially the big IT companies nowadays, are using some non-traditional DBMS products. The reason for that is because there are new types of data nowadays. For example, videos, images, audios, even social media data such as social network data. They cannot be processed by the traditional DBMS products such as Microsoft Access. That's why many companies starting to develop those non-traditional DBMS products such as NoSQL DBMS that support high transaction rates, simple data structures, replicated on many servers in the cloud. And there are some examples, those are the examples of the non-traditional DBMS, such as Dynamo, which is developed by Amazon, and Bigtable, which was developed by Google, and Cassandra, which was used by Facebook. So for you guys, you just need to be aware the existence of these types of non-traditional database. So that's it pretty much for this chapter. And the most important takeaway for this chapter is the purpose of database and why it matters for information systems.